Hello, this is about artificial intelligence through my channel AI Nexus. Please do subscribe to that. I'm Dr. TV Geeta, and in this particular video, I will be talking about the smartest type of AI learning, unsupervised and semi-supervised learning, a very interesting type of machine learning. So, unsupervised learning is a type of machine learning where the feedback is not provided at all, but provided in a different way. We'll see that. Unsupervised learning, the training data does not come with the desired output or correct outputs, which means there is no teacher there. Now, let's take an example. You have input images and then you discover patterns from the features associated with the input data. And the unsupervised learning model is what is learned. And then the new data is clustered into groups. And when a new data comes, it is put into one of these clusters. So that's how you gain insight. And you are learning from unlabeled data to discover patterns or structures associated with the different ones based on similarity or statistical property. And you may find natural groupings, you may detect patterns, you may sometimes reduce complexity, and you may reveal hidden relationships also. We said there is no feedback signal. There is a feedback signal, not explicitly given by an external agency, but there are internal measures which talk about similarity, distance, and compactness of groups and so on. There is a risk here that you are focusing on error minimization, so there may be overfitting, and sometimes the clusters or patterns that you find may be mathematically meaningful but may not be meaningful otherwise. Now, let's some examples are grouping customers by buying behavior, fraud pattern discovery. Fraud detection can also be done using supervised, can be done by unsupervised also. Topic discovery in documents, grouping news articles depending on the topic of discussion. Patient risk grouping depending on the symptoms or the clinical data and so on. So the common tasks associated with unsupervised can be divided like this: clustering, grouping similar data; dimensionality reduction, simplifying data while keeping important information; association discovery, finding when two items or three items occur frequently together; anomaly detection, that is detecting rare or abnormal behavior from the normal behavior; density estimation, learn the shape of the population where points are common or rare. Now, it improves iteratively. Let's see how this happens. So you give raw unlabeled data, no target labels. That is unsupervised. And then you give it to the unsupervised model. It learns the pattern discovery, clusters or whatever. And then feedback is given. That is distance within clusters, density, reconstruction error. This is given by the system. Sometimes pattern usefulness is given by human feedback or domain, and some business feedback also. Then you ask for better patterns. Okay, so you evaluate it, adjust the model, and then improve. So this is an feedback. It's an iterative improvement based on the internal feedback measures that are used. Now let's take an so what the model learns patterns from unlabeled data and uses feedback, okay, not labels, to improve its iteratively. So that's what we're doing. A real world analogy: sorting students into study groups without knowing grades. So initially you group randomly, okay, you don't know. Then observe who discusses well together, who struggles together. Rearrange group based on the interaction patterns. Repeat until groups feel natural. So you are not telling, not using an explicit information. So the interactions of the student is actually the feedback you're using. Now we go to the next type of connected learning, which is semi-supervised learning. This is again a type of machine learning, again based on the feedback given. So semi-supervised learning, the feedback is partial and indirect. It's a hybrid model, a bridge between supervised and unsupervised learning. So if you look here, you will see that you have a small amount of label data. So that is given to the supervised model, and then a large amount of unlabeled data, because it's very difficult to get labeled data. That's why we are going for this. So that is given, and the features learned, and then you give it to the ML model, and then you have a pseudo label set, that is using that small data set and this you are labeling. Then again you give it to the machine learning model, and then you get the prediction result. So you are using the supervised learning part to create pseudo label data set. So from a small amount of label data, you are guiding the learning, and then a large amount of unlabeled data to find the structure of the data space. So the learning process already, as we told you, predict on the unlabeled, select the high confidence predictions, treat them as pseudo labels, combine and iterate. So the partial feedback, that is the crux or the concept. And if two data points are close in feature space, they are actually similar. That's one assumption we make. Then data from clusters point in the same cluster are likely to share a label, and decision boundaries should lie between clusters, not through them. So pseudo labeling is another concept we talked about here. Model predict labels for unlabeled data. So high confidence predictions are treated as pseudo labels or temporary labels. Wrong prediction here may reinforce the wrongness or errors. Real world example, medical image diagnosis, train for say 200 label, easy to do that, and then predict for 10,000 scans. So this is used in cancer detection, tumor classification, disease screening. Speech recognition, train on small label speech data set. This is easier to get, and then predict on millions of unlabeled. Essay, 150 teacher graded essays, and then predict on 8,000 ungraded essays. Similarly, customer review, you do only for the 300 labeled reviews, use that for predicting the sentiment of 50,000 unlabeled reviews. So the semi-supervised learning again is a feedback basis only. The nature of feedback is few examples have correct answer. So we have seen how it is done. The small label data is used for guiding learning, and the large unlabeled data is actually to find out the shape of the decision structure and adjust based on the internal patterns. So the feedback signal is a label error and the data structure. What the model learns is that a small amount of feedback can guide the large amounts of data. Labeled data acts as anchors and sets a direction. Unlabeled data shapes the boundary. Hidden risk is, again as we told you, wrong labels, error spreads. So this is unlike supervised, feedback comes partly from pseudo labels, not always from real labels. Unlike unsupervised learning, feedback does exist through labels actually given and the pseudo labels. This is important because in real world reality, real world data is mostly unlabeled and labeling is expensive. So if you label only a small data set, you can label huge unlabeled data sets. So it's a sort of cost-effective learning. Real world detective solving crimes. Some crimes have witnesses of CCTV evidence. So that is the labeled data. Many crimes have no direct evidence. So unlabeled data. So detective uses known cases to predict who are the predict the offenses or patterns in unknown cases. This is the pseudo labeling. And then feedback comes from confirmation, court verdicts, arrests and so on, and the model improves over time. So labeled is known cases, unlabeled is unknown cases, pseudo labeling is hypothesis that you get, and feedback is the verification. So let's compare this unsupervised and semi-supervised learning. So labels used, unsupervised, no labels, semi-supervised, few labels. Data used, only unlabeled data. Here we use labeled as well as unlabeled data. The goal, discover hidden structure or patterns, find the structure. Here, improve prediction using both structure and labels. Use structure to improve the supervised learning. Output difference, no predefined categories. Model creates its own. Here there are predefined categories and model learns to assign the correct labels. Decision boundary, it's not primary here. It's very important. Here it is pure pattern discovery. It is hybrid learning and semi-supervised. Real world use, it's an exploration type of unsupervised learning is. Here it's practical deployment. Example, customer segments based on buying behavior. Here spam versus spam using few label emails.